going to do some modeling for you.
Oh, wow.
Geometrically. Because please keep
okay. I was gonna
all clothes.
Behold, the hoodie, the fleece. This
Yes,
is a
formative
geometric
arrow.
model. So we're going to talk about random variables that have what's called the geometric distribution.
Mhm.
Okay, it's a special kind of random variable.
It is.
It's about weighting.
It is. It's all life is about, waiting.
Okay, you don't have to tell seniors that, man. They got that. Oh. All right, June is coming. We are dealt cards with replacement from a deck. So suppose we're dealt cards.
Mm-hmm.
Each card is dealt, put back in the deck, and shuffled. Let X be the number of cards it takes to get the first spade.
Right.
So we're waiting for a spade to happen.
Right. So if it was happened on the first time, that would just be the probability of getting a spade,
Yeah,
which would
so
be
probably X equals 1. You got to think what that means. That means the first card is the spade.
right. And there's a 1/4 chance that that'll happen.
Okay. Let's calculate the probability that it's the third card. So the first two cards are non-spades.
Mm-hmm.
So we often talk about this in terms of failure and success. Success is whatever you're waiting for.
Right.
So getting a spade is success. So the probability X equals 3, we have to fail twice.
Right. So I'll fail once,
Yeah,
and I'm going to fail twice,
yeah.
and then I'm going to succeed.
Good for you, man.
Because at first you don't succeed, try again.
Yeah, so if you multiply that, that'd be 9 out of 64.
It would.
I need a calculator here.
Yeah, because we're going to probably have to move to decimals pretty fast.
So more than a 10% chance.
Okay.
Okay.
Now, X equals 5. Now, there's got to be a faster way than just writing a bunch of
Let's write it
failures
out
in a
one
row.
time. Let's. So
Yeah, you want me? He just wants to make me right.
this means we have to fail 4 times. First one's a non-spade, second one's a non-spade, third one and fourth one are not spades. The fifth one is a spade.
Yeah, finally we get a spade.
Okay, so it's 3 to the 4th, which is 81,
Yes, it is.
over 4 to the 5th. Don't know what that means. 4 to the 5th is 1,024. So if we want a decimal, 81 divided by 1,024 is 0.079.
Okay, so like
So
an
it's-
8% chance that's
Yeah.
going to happen.
There's a 25% chance that it happens the first time, and then it kind of drops down after that.
Right.
Now, certainly we can use exponents this time. So it might take 20 tries for you to get a spade.
Yeah, we
Because
could be
remember,
really
we're putting
bad
the
at
card
this.
back into the deck each time. This could really go on for
Yeah,
a long time.
Could be a brand new deck and the spades are all the way at the bottom. You have no idea.
Well, we're assuming it's shuffled.
Nah.
All right. So you'd have to fail 19 times.
Right, so that would be 3/4. So instead of writing it out 19 times, we could just take that to a exponent.
Could you write it out, Mr. Willis?
Yeah, no. You multiply that by 1/4.
And, okay, we can figure out what the decimal is, but it's going to be probably pretty slim. Oops. Sorry. I have to get used to the new format here. There is a 0.1% chance of that happening.
All right.
So a very small chance. It's going to take 20 tries.
0.001. Bam.
Okay, let's find the probability it's going to take k times. So this is kind of general formula.
Yeah. So we would have basically our failure rate. So that would be 3/4. Okay. Now, if it happens k times, that means I have to fail one less than that.
Right. So like in the 20, we had to fail 19 times.
Right. So that'd be k minus 1 times my success, which would be 1/4.
All right, so Mr. Lewis, don't move this yet. We want to write down these values for what we do next. Okay, so we want to start by writing a probability model.
All right.
Okay, so let's hit the next slide. And we're just going to start writing this out. So I'll draw a big line, and let's let the top row be the values of x, and the bottom row the probabilities.
Okay.
Okay, so let's start writing this model out. So probably x equals 1 was 1/4.
Was.
The next possibility is that the second card is the first spade.
Oh, 2.
So we didn't work this one out, but it would be, you have to fail once and succeed once. It'd be 3/4 times
16.
1/4. Right. The third one we did. So the probability that the third card is 9 out of 64. The fourth one we didn't do, so let's put 4.
4.
Yeah. And maybe down here, because we're gonna need the space down here. Probably happens on the fourth one was we have to fail 3 times
Mm-hmm.
and then succeed once. So that'd be 3/4 to the third
Mm-hmm.
times 1/4.
Mm-hmm.
Okay, so that'd be 27.
Mm-hmm. Over 256.
Yes, thanks. Okay, and then you could draw the line, but we could keep going because it could even take 100 times, even though it's not likely.
Yes.
So one thing I want to point out, there are an infinite number of possibilities.
Yeah.
So it could take 1,000 times to get a spade. It's just extremely unlikely.
Mm-hmm.
So maybe put a big ... there. So we can't quite write out the probability model like before because there's an infinite number of possibilities.
Right.
Okay, next slide. But there are formulas for expected value. That would be
Yes.
how long we expect to wait before we get a spade. So remember, x is the number of cards before we get a spade. So expected value of x is, on average, how long it will take.
Yeah. So on average, if it was a 4th chance to win, so that'd be 1 over 1/4.
Could you put a parentheses around that 1/4? Because when you're doing this on the
Could.
calculator, you gotta remember we're dividing by a fraction.
Yeah, and when
Your
divided by a
parentheses.
fraction, it's the same thing as multiplying by the reciprocal. So that means I'm just actually ended up with 4 times.
Now, P is a probability of success.
Yes.
So P and Q we're going to be using a lot in the formulas the next few days.
Mhm.
And so P's probability of success and is probably getting a spade. All right, so for the variance, remember sigma squared is the variance.
Mm-hmm.
So it'd be Q, which is 0.75,
Yeah,
or 3/4.
3/4 over 1/4 squared.
So probably want parentheses around the top too, if you're doing it all at once on your calculator.
Another reason decimals can be a little helpful here.
And we get 12. And so sigma is the standard deviation, it's just the square root of that. And so square root of 12 is about 3.5, it's 3.46. So on average it's going to take 4 tries to get a spade, and that's the standard deviation.
Yep.
Okay, next example. We'll go through this kind of quickly. All right, what's the setup?
All right, suppose 3/10 of the school are freshmen. We randomly select students who are freshmen. Let X be the number of students that we select before we get one. We're also assuming that we are putting the freshmen or putting the kids back.
Yes,
Right.
so with replacement.
Right. So you're imagine you're sitting in the auditorium, the whole school's there, one kid comes up on the stage. If they're not a freshman, we send them back.
Yeah, and there's a chance that they could be selected again.
Mm-hmm.
All right, so with replacement kind of like cards. So probably X equals 1. It's just 3/10.
Right.
That's probably the first guy's a freshman. Right, probably X equals 3, got to fail twice. So 7 out of 10 times 7 out of 10 times 3 out of 10. And let's just leave it like that.
Okay.
Probably X equals 5 would be 7/10
7/10, and now
To
I'm gonna get lazy.
to the
fourth
fourth times.
3 out of 10.
Leave it like that. We know we can get the decimal if we want.
Yeah.
14. Got to fail 13 times.
Yes, you do.
13 non-freshmen. So there's your 13 failures, and there's the success.
Right.
And so we can calculate these probabilities for any value of X you want.
Mm-hmm.
Okay. Next, let's see how much on average. Oop, I went 2. We both hit. So back one.
No, that was it.
Oh,
We,
that's.
we didn't do it on average.
Oh, okay.
Do you want to?
Yeah, let's do it.
Okay.
So,
So we'll do an E of X.
right. So it's 1 over P.
1 over 3/10, which is the same thing as 10 over 3.
It's about 3.33.
Mm-hmm.
So actually, on average, a little bit over 3 students to get a freshman.
Yes.
Okay, let's do just the standard deviation. So sigma is the square root of,
It's the square root of 7/10
yeah,
over 3/10 squared.
boy. So when you're doing this, I would highly advise like working out the inside first.
Yeah, I would do one at a time.
So
Until
square
you get
root
really good.
of 0.7 squared, 0.7 divided by 0.3 squared All right, I get about 2.79.
which makes sense.
Okay.
Okay.
All right, now it's time for the general assignment.
Okay.
So here you go.
All right, so we're going to go back to cards. So we want to know X is the number of cards it takes to draw a face card. So assume you're dealing with replacement. All right, so here you have, here's the probabilities we have. So probability takes 1 card, takes 3 cards, 5 cards, 14 cards, and then calculate the expected value, the variance, and then the standard deviation. And we were so nice and gave you those formulas right here.
Yeah, remember P is the probability of success, so the probability you get a face card. Q is the probability you don't.
Right.
All right, good luck.